Okay. Hi, Megan. Can you hear us?
Oh, yeah, I can hear you.
Okay, wonderful. If you want to share your screen, I mean, we see your screen, but not the slides.
Yeah. Okay, can you see them now?
Yeah, great. Okay, thank
Okay.
you. So now we have Megan Katsumi from the University of Toronto presenting toward requirements for an ontology of asset management. So Megan, you have 20 minutes plus 10 minutes discussion. If you please can keep your eye on your clock because it's difficult to tell you from the platform how time is missing. How
Right.
much time? Okay, thank you
Sure.
very much.
Sure. Thanks, Emilio. Hi. So, hello, everyone. Just a little bit strange experience, but I'm happy to be here. And today I'm presenting some work by myself and Tony Huang and Mark Fox. And this is some preliminary work that we've been doing toward requirements for an ontology of asset management. And this is part of a project that's ongoing between the University of Toronto and Toronto Water in Canada. So, for a little bit of background, Toronto Water is a publicly owned organization, and they're the owner and operator of infrastructure that's responsible for treating and distributing drinking water, and as well as collecting and treating wastewater for the residents and businesses in the city of Toronto, as well as some neighboring municipalities. So specifically, we've been working with the asset management group at Toronto Water, and they're responsible for a large number of assets across the city. So things like water treatment plants, pumping stations, sewer mains, and so on. And in this role, they play sort of a key part of achieving the primary goals of Toronto Water as a whole. And those are to meet customer demand. So in other words, to be providing people with drinking water as required and treating the wastewater that's generated, and to maintain the quality standards, as well as ensuring the safety of employees and the public. So that's like, going beyond just making sure that the drinking water is safe, looking at things like safety of operations, and so on. And then the final goal is to do all of this at a minimum cost to the public, because this is, taxpayer dollars. So that's important. Um, so in general, at least at Toronto Water, when we talk about asset management, we're looking at they're responsible for making decisions about repairs, replacements, and maintenance of assets. And to do this in sort of a well-considered, well-informed way requires actually a lot of information. So they need to look at things like the asset's condition, its history, the design of the system that the asset's operating in, as well as the performance requirements for the system that the asset's operating in. And they need to also know about various different types of costs. So the cost of the asset's acquisition, cost of repairs, um, cost of failure, and things like that. So in this way, information management actually becomes a really key part of asset management. So, for example, in for the group at Toronto Water, they may need to answer questions like, does the flow rate of some asset meet its required performance, or what particular types of electrical assets are found in some particular type of environment. And to answer these questions often requires the combination of data from multiple systems. So, for example, to answer the first question, we might need to look at one data system to determine the role that the asset is assigned to, or the role that the asset occupies at a particular point in time. So that might be like in the work management system. Then we need to look at another data system to figure out what the product line of the asset is. Then we need to refer to another data system to figure out what the capabilities of that product line are. And then, maybe one more data system to figure out what the requirements are for the role that the asset's assigned to. So, answering these kind of questions does get really complicated, and it's partially because of the number of data sources required, but it's also due to the presence of data silos. And I'm sure we have seen a lot, and we'll see a lot of content on this kind of issue during this workshop. But at Toronto Water, much like many industrial organizations, we have these data systems and data stores that have evolved independently over the years, and this has led to these disparate data models, which are difficult to harmonize, and making it really difficult to combine data between them. So this results in, the need for time-consuming IT requests for reports for information, and sometimes the need for manual retrieval and integration of information, which makes the work of the asset management employees, a little bit less efficient than it could be, and less effective sometimes. It also creates the some data quality issues because by having these data silos, there's opportunity for inconsistencies to kind of persist across the different information systems because it's really hard to detect when they arise if we don't have any integration between them. So the project that we're working on with Toronto Water is intended to kind of address these challenges with an ontology enabled data hub. And we've identified three sort of key development initiatives so far toward this, which we'll be talking a little bit about today. The first is what we've called the historical data hub. The second is a content metadata initiative, and then the third is a data entry initiative. So the data hub is the tool that will really integrate all of the different data systems. It will implement mappings from the data systems into the language and the ontology in order to achieve semantic interoperability between the different data systems. And in doing so, it also provides a single point of access to all of the data stores. This on its own, this already sort of lowers the barrier of access to information, as well as potentially improves the quality of information because we're able to do some kind of, consistency checking or country checking across data systems, as well as potentially the propagation of data updates. But the Data Hub also provides the opportunity or sort of a foundation upon which we can develop more sophisticated applications. And those are sort of, we'll beginning with the applications that we're looking at today, or the development initiatives. So as mentioned, it's really important for the asset management group to have the ability to refer to historical information about an asset, and that's really the main requirement that we're trying to address with the historical data hub initiative. So its purpose is to provide this ability to look back on assets history, as well as on the other side to record changes to knowledge that have been made across the data systems. It is meant to also track and understand these changes. In particular, we need to be able to distinguish between reflective changes. So these are changes in our information about an asset that may have resulted due to things like work orders or capital projects, versus corrective changes. And these are the result of things like reconciliation activities, where we recognize that the information that we have doesn't correspond to reality. So a change is made there, but it's not, we don't really know what caused that change in, like, let's say the assets state or something like that. It could be that it was just entered incorrectly by accident or something. The second initiative that we're looking at in this project is related to content metadata. So finding documents is another really important task for the asset management employees, and obviously it's ideal that they don't spend too much time on the search for relevant documents. And so the idea is that we can use the ontology in this context to support the existing content management system at Toronto Water. So we can use the common vocabulary to describe documents in a useful way. So, for example, what asset or class of assets the manual refers to, and this should improve the search capabilities for the asset management employees, and also we can use the information in the data hub to better sort of maintain the metadata for the content that we have. So, for example, to reflect changes in knowledge about the assets, if we needed to, find all documents related to a specific role and the asset assigned to that role has changed, that's relevant for what documents we're going to retrieve. The last initiative that we have identified so far is the data entry initiative. So this is another kind of important area. So when we have capital projects or when work orders or other things are done, the data is input, in different ways into the different data systems at Toronto Water, and this is an area with a lot of potential where we could potentially gain a lot from the use of the ontology. And the idea being that we could leverage the definitions of the ontology to support data entry, the task of data entry, but also to check for errors in input. And this would both streamline the process for users, so the people, the employees, or the consultants who are entering the data, and also reduce the opportunities for error. So it, would have the effect of improving the quality of data available to the asset management group. So an example of what we have in mind for this initiative is, let's say, if somebody's inputting information about some new pump that was just acquired, there's really no need for them to see all the different types of information that you could input about an asset, but only those that are relevant to a particular pump. So this kind of speeds things along and also reduces the chance that they might input incorrect information. Okay. So what about the ontology that we'll be using to support all of these applications? There is a lot of existing work out there, and I think we'll probably continue to see some of that during this workshop. So there are asset management ontologies, the maintenance ontologies that we think will probably provide a lot of useful concepts, or the concepts that we may need for this work. And there's also foundational ontologies that exist out there, describing things like time and provenance. So the question being, how do we know, or how do we choose which of these ontologies we can reuse? And the foundation for making this decisions is really the requirements for the ontology, and that's what we're really talking about in this paper. So we implemented, or we followed the ontology requirement specification document methodology. And that's what's been presented in the paper for this work so far. And this is really just a series of steps that's guided by a template. But what's nice about it is it gives us a systematic approach to requirement specification, which is really useful for a project of this size. The methodology itself is fairly straightforward. They've identified sort of 7 main steps. And we haven't really focused on, we've omitted the steps of grouping our requirements and prioritizing them. But I'll sort of go through what we've done for the first development initiative in the next couple of slides. So rather than, try to define a single specification or a single template for all of the initiatives, what we've done is we've kind of approached them on an independent basis for now. So this is the template for the historical data hub. So the purpose of the ontology in this context is to define the key concepts used across asset management in a way that will enable the history to be maintained, while also enabling integration between systems so that we can produce a comprehensive asset history. That requires the ontology scope to capture assets and roles and the ways in which they change over time. It also needs to represent data systems and the records that describe these assets. So these are kind of like the first couple steps of the requirement specification, where we're just talking about things at like a high level based on what we know from our discussions with Toronto Water. The next step is identifying the implementation language. So for now, we've specified that the ontology should be defined in OWL, though we've sort of said that there can be flexibility for extension in other languages. as required. And then the intended end users that we identified were in two groups. The first is the asset management manager, and the second is the asset management analyst. And we sort of talked about this a bit already. So needing to know the history of the asset, so things like replacement history, as well as histories of failures, test inspections, and outcomes, so that the asset management analyst can make decisions and infer things like expected useful life of a particular asset. We identified two intended uses for the ontology in this context. The first is to track changes, so to keep track of key pieces of information about assets and roles and how they change over time, as well as the cause of the change. As I mentioned, there could be changes caused by work that's performed, or there could be changes that have occurred as a result of some kind of corrections. And the second is to actually retrieve the information. So the ontology should be able to support the retrieval of this information at specific points in the past. We identified three non-functional requirements. This is another step in the specification. The first is that the ontology should use terminology that's familiar to and easy to understand. And the second is that it should enable intuitive construction of common queries. And the third is that the task of updating data with the ontology should be straightforward. And these are fairly generic, but I think they're important. They're important to recognize. The next step is the identification of the functional requirements, and this is done with competency questions, which are a fairly well-known technique. So it's essentially specifying queries that the ontology should be able to answer. And these sort of range from fairly simple to more complex. Some show the status of a role at a given point, and if applicable, the asset that's serving in the role. And then another competency question, number 7, is given an asset or role record in a data system and the set of all changes in a given time frame, which subset of changes were made to correct mistakes versus to reflect actual status changes. And then the next step after the identification of all the questions is to generate what they refer to as a pre-glossary of terms. So this is essentially like a list of all of the terms that arise in the competency questions. So there's no distinction, if they're roles or classes or whatever, but just a list of the terms. And in our case, it's things like change process, time frame, asset, role, organization, input, and so on. These can be more or less, these are really the requirements for the concepts that need to be in the ontology, at least in part. And we can summarize these requirements so far as the need for representing physical assets and their classifications, the roles that the assets occupy, processes that result in changes to the assets and the roles, and provenance of knowledge about the domain. Okay, almost done. So the next steps for us in the project will be to complete a detailed survey of related ontologies with respect to the requirement that we identified. And in the meantime, or in parallel, sort of, we're working on understanding or developing a more complete understanding of the intended semantics of the requirements that we identified. Following this, we'll be working sort of iteratively on an implementation and design. So we'll start with a sort of proof of concept implementation of the data hub. And the idea is sort of to keep the implementations, the development small and manageable, so that we'll have something to show stakeholders earlier on to, explain what we're doing, but also to kind of continue to get their buy-in on the project. And then iterate. So at each iteration, the idea is that we'll be expanding the scope slightly, likely revisiting the requirements and implementing and testing. So I just want to conclude by sharing a few of the insights that we've had so far. At least, a few of them. The first is regarding non-functional requirements. And I mentioned this already, but at least the ones that we've identified in our requirement specification, we recognize, and the reviewers also recognize, that they are difficult to evaluate. but we think nonetheless they should be stated. It's important that we kind of keep them in mind and recognize what they are. And at this point, it's an open question for us if there's a better way to specify them or a better way to evaluate them. But for now, they are as they are in the document. The second point is that the requirement specification is a good start, but there's still a lot of work we have to do. There's many design choices to be made, a lot of review to be done. In particular, as I mentioned, the clarification of the intended semantics. So it's one thing to have a list of terms from discussions, but it's quite another to really have an understanding of what is meant. Not just for asset management, but for asset management at Toronto Water by each of the terms. What do they mean by role? What do we need to represent? And so on. So that's already been the basis for some considerable discussions, and that will likely continue. Also, the level of detail that's desired versus the data available. There's certainly maybe some sort of tension between those two, and that's something that also kind of needs to be better understood and considered. And also, we're expecting some continued conversations about or discussions, decisions to be made about implementation versus semantics driven design choices. So there are, and likely will continue to be some discussion around definitions that may be more, better implementation wise versus ones that may be more accurate. And then finally, on a more optimistic note, we also wanted to, or we've observed that the requirements that we've identified so far really suggest a generic kind of widely applicable representation. And what we're seeing so far is that a lot of the Toronto Water specifics, will likely be captured more or less in extensions and in the asset classification. So our thinking and our hope is that both the ontology and the applications that we're working on may be something that's beneficial for the broader community as well. And that's it for me. So if we have time, I'm happy to take any questions now.
Okay, Megan, thank you very much. Is there any question from the audience? Yeah, we have one question here. Thank you for your presentation. I have a question. So you told us that you want to employ ontologies in order to facilitate searching for information. You mentioned I think that you mentioned that you want to use ontologies as a common vocabulary to describe in a standardized way, I suppose, the documents, and then so it is easier to recover information. Could you elaborate about this in particular? Do you do you have a set of tags, I don't know, that then the employees search? When a user searches for some information, does it search an unstructured text field or something like that?
Oh, you mean for the current case? Or what's the ideal, what are we thinking about for implementation?
Yeah, what do you want to do? And also, what is it now versus what you want it to be?
Right. So I can't give as too much information about now, or I don't know if we have time. I think Tony is probably somewhere in the audience, and maybe he can add more. I know that right now they're using Ontotext, and from what I gather, it's a relatively simple kind of keyword search. I don't know what the sort of parameters are that are supported. But the idea, I think, would be to use the ontology as a way to kind of annotate the documents. I don't think it wouldn't be anything too complex, but maybe you can tag the documents using and as I mentioned, this is sort of the third initiative. We haven't really done too much on this other than sort of identify it as something that we will be pursuing in the future. But the idea would be to, I think, just kind of be adding these tags using the language ontology to the to the documents on the one hand, where they're stored, but then also to capture that as part of the data hub so that we can refer to the other relationships in the query and potentially actually post the query rather than through something like OntoText, but through the data hub to get a pointer to the relevant document. So you're not just looking up the certain keywords, but maybe you're looking for, manuals of assets that have been in this role or something like that. Does that kind of, have I explained that clearly enough?
Okay, so there is in the chat a message from Tony Wang. I think he's also commenting
Oh,
on this.
yeah.
Yes, we do plan to annotate. Okay.
Oh, sorry. Yeah.
Is there any other question, comment? Yep.
No problem.
I don't want to say ladies first, but thank you for waiting.
You were faster.
Yeah, I will try. My question for you is, you talk about metadata. So I really want to know that if you have chosen a specific ontology, such as a dataset catalog or something like that, to model metadata for your data hub.
No, we haven't. We're still sort of in the earlier stages. I think in terms of modeling, I mean, metadata is that's like a broad. It's a broad description. I mean, talking about for the data hub, for uh, metadata about the document is something different versus metadata about the actual records, which is a kind of another requirement that we have. So some of the things like we've been looking at, potentially we may need to use the Provo ontology. We haven't made decisions about all of that stuff just yet, but that's kind of something that we're coming up to soon. And with the data catalog representation, maybe something that we'll use when we're looking at the search implementation, but we haven't made any decisions yet.
Okay. Hi, Megan. Good to see you again this term. You mentioned the design decision about implementation versus semantics. Can you dive in a little bit more on that? I'm not sure if I, follow this.
Yeah. I mean, so that's something I mean, this is not specific to probably to any like any application. I think it's kind of a general thing for any kind of applied ontology. But like, let's say for a representation of, like changing information, like I mean, that's kind of like one of those this core requirement that we talked about. Um, historical information of assets. So we want to know not just like what's the status of the asset right now, but we want to be able to sort of refer to or look at how the status might have changed over time versus like when it's installed, if it's out of service and things like that. Um, so there's a lot of different ways that you can do that, and I think sometimes what it comes down to in terms of the representation is a consideration not just of which way is the most correct way to represent it, or which way maybe supports uh, all of the things that we want to define. So there's different ways to represent that, like in owl, for example, like you could represent that using like four-dimensionalist sort of approach. You represent it with like reified like entity relations, but then you also have to look at what that does from the implementation side of things. And there's other arguments then that are maybe made for using something like RDF star in the implementation, even though we might be able to then actually capture all the definitions and the constraints and things like that, in OWL. But maybe that's something that we need to consider because from the implementation side of things, maybe that sort of those OWL-based definitions don't lend themselves well to the representation or to the instances and the queries that would then be required for that.
Okay, Megan, thank you. I have a question also from my side. So, I mean, From a foundational ontology point of view, sometimes people criticize, let's say, the use of competency questions because they do not capture in the way in which they are used, let's say, foundational aspects concerning identity, persistence, and so on. As you were mentioning, they're mostly, let's say, query answering problems. So they do not, they are not meant to represent these sorts of foundational aspects. Can you comment on this?
Yeah, I mean that's a kind of a fair. It's definitely a fair point. So I guess what I would say is that really, I don't think they provide a complete representation of the requirements, or like it's kind of a funny thing, because really the requirement specification at a certain point starts to bleed into the actual design of the ontology, as you're trying to understand what are the intended semantics of the different terms. So I think competency questions provide a really good and effective sort of starting point to understand what's the required scope, um, and the terms, and give you a basis for then diving into some of the more foundational sort of questions, like, okay, what do we mean by role? How are we meant to define it, and things like that.
Okay, Megan, thank you very much. And let's move now to the coffee break. So thanks again.
Thank you.
So we're a bit late, so let's try to be back at 16:50, so that then we are not too late for the closing. Thank you. For 16:50.
Okay.